All right, so the fundamental theorem. There's two parts to the fundamental theorem. We're going to tackle the evaluation part today. Okay, so the fundamental theorem of calculus, it's the fundamental theorem because part one involves integration, part two involves derivatives, differentiation. And those two things are by far the biggest things we cover in calculus. So because it covers so much of what we do, it's called the fundamental theorem. Okay, the fundamental theorem of calculus is a theorem that links the concepts of differentiating a function, finding a derivative, with the concept of integrating, area under the curve, which we're working on. Okay, it is the most common method we will use in this class to integrate, to find area under the curve. This is the way we're going to use finding area under the curve the most often. The other ways we will use, but not as much as this guy right here. Okay, there are two parts to the fundamental theorem of calculus. Today we're going to cover just the first part, which is the evaluation part. Okay, so what is the evaluation part? It's right here. Okay, so if f is continuous over a function, a to b, over the interval, sorry, a to b, and capital F is any derivative of f of x, then, so mainly focus on the blue and the green. I know it's not on your paper, but so if we are finding, so now the fundamental theorem tackles integrals with bounds, right? We haven't seen bounds in a while, but the fundamental theorem talks about bounds, okay? So if you have a bound here from a to b of a function, what you're going to do is you're going to find the antiderivative of that function, just like we've been doing. Nothing different. And then once you're through with that, you're going to evaluate it from b to a. What does evaluate mean? It just means plug in and subtract. Okay, so this is really the new part here. But you guys, evaluation just means plug in. And then after you plug in, you subtract. Example here. Here's an example. So this is the guy right here that we are finding area under the curve. We're finding area under the curve for 3x squared. That's the function. Parabola. From 1 to 5, where x equals 1 to 5. Okay, so the first thing we do is find the antiderivative, which is x to the third. Add 1 to the power, divide by the new power. And then evaluate from 5 to 1. So I plug in 5 for x, plug in 1 for x. I get 125 and I get 1, so I subtract them and I get 124. That's it. That's the area under the curve from 1 to 5. Okay, that's called the fundamental theorem of calculus. That's exactly what it is. Now, the only thing is when we're integrating, when we're finding antiderivative, you might need to use U-substitution, but you already know how to do that. That's why we do U-substitution before that. That's the hardest part. The hardest part with this guy is U-substitution, and you guys practiced that last week. Okay? Overall, it's not very deep. It's not a very hard theorem. Okay? Capital F. If you see capital F, it just means it's the antiderivative of f. Like f prime is the derivative of f. Capital F, if you see a capital F, it just means the antiderivative of f. So in other words, f prime is equal to f. The derivative of the antiderivative is just the original. Okay? Part 2, you're going to be seeing a lot of these symbols here. Okay? So sometimes I'll say the f. Sometimes I'll say capital F prime. They're the same thing. Okay? All right. Okay, so let's look at example number 1. The antiderivative. So we need to find the integral, the area under the curve, from 1 to 2. X equals 1 to x equals 2. And there's the function. Here's the function here. Can we use just basic power rule for this guy? Or do we have to use U-substitution? That's the first step. We can use regular power rule, right? There's nothing special about this guy. So that's what we'll do. First thing, find the antiderivative. Okay, so the antiderivative is, let's see, negative 15 x to the third divided by 3 plus 6x squared divided by 2. We don't need a plus c because these have bounds. Instead, we're going to write a line and a 2 and a 1. That just means we have to evaluate it from 2 to 1. Okay, so I'm going to simplify that. Negative 5x to the third plus 3x squared. And then now I need to evaluate it from 5 to 1. Or sorry, not 5 to 1, 2 to 1. Evaluate, just plug in. Plug in 2, plug in 1. Okay. Anywhere I see an x, I'm going to plug in a 2 first. So negative 5 times 2 to the third power plus 3, 2 squared. That's the first one. I'm going to do the same thing, except instead of a 2, I'm going to put a 1. So negative 5x cubed, instead of an x, I'm going to put a 1, plus 3x squared. Simplify and you're done. Okay. So let's see in here. Let's see, negative 40 plus 12. Remember to do exponents first before you multiply. The next guy, I get a negative 5 plus 3. Let's see, over here, I get a negative 28 minus a negative 2. Negative 26. That's the area under the curve from 1 to 2. So what does that tell me about the area? If I was to actually graph this guy, what does that tell me about the area? What do you know about the area? It's got to be below the x-axis because it's negative, right? It has to be below the x-axis, otherwise it would be positive. Okay. All right, next one, number 2. Okay, same thing. Now we're evaluating it from negative 1 to positive 1. So on this guy, can I use the regular power rule like I did the last time? No, right? This one won't work, so I have to use U-substitution. Okay, we did that last week. That's all we did last week. So now, first thing I'm going to do is rewrite it so it doesn't have, same thing I did last week. Rewrite it so it doesn't have a fraction, there's no division, because I don't have a quotient rule. I have a U-substitution, but I don't have a quotient rule. So it would be negative 3 power. Okay. So I think this guy is going to be the U because it's the argument. If not, we'll switch it up. Okay. So U substitution, U is 2x to the third plus 3. Du is 6x dx. Divide by 6x, just like we did yesterday, or last week. Nothing has changed from last week. So far, I'm doing everything I did last week. Haven't changed anything. Oops, forgot a squared. Should be 6x squared. Okay. Do what I did last week, plug in. -1 to 1, 4x squared stays. I put u, because that is u to the -3 power. And then I sub in for dx. I know dx is now 1 over -6x, positive 6, x squared du. Okay. The x squareds will cancel out. Okay, let me rewrite it. I have -1 over from -1 to +1. And then I have 4/6. U to the -3 power du. Well, 4/6 is just 2/3. So let me cancel that. 2/3. And I'm going to move that to the front. So 2/3, 1 -1, u to the -3 du. Okay, I haven't found antiderivative yet. I got to find antiderivative. Okay. So 2/3. Antiderivative is -2 divided by -2, which is just -1/2, really. Dividing by -2 is the same thing as multiplying by -1/2. And then I got to evaluate it from 1 to -1. Okay. Fractions will reduce. Move in back what was there before. So I get -1/6 u to the -2. And then I have to evaluate it from 1 to -1. 1/3, yes. Yep, -1/3. Okay. Put back what u was. U was 2x cubed plus 3. Usually that's where we'd end with U-substitution last week. Now we have to do the evaluation part. Okay. So it's probably easier. This guy has a negative power. It's probably easier to change it back. So instead of a negative power, move it back to the bottom. It's probably easier. So -1/3. And then 2x cubed plus 3 squared would be down here. You don't have to do that, but it's just probably easier. And then plug in 1, plug in -1, subtract them, see what we get. Okay. Simplify, subtract, see what you get. Let's see. So on bottom, 1 cubed is 1 times 2 is 2 plus 3 is 5. 5 squared is 25 times 3 is 75. So 1 over 75. Negative 1 is going to give me not the same answer. Negative 1, let's see, negative 1 cubed is negative 1 times 2 is negative 2 plus 3 is 1. 1 squared is 1 over 3, negative 1/3. Okay. Let's see, 2 negatives, so it's going to be positive. Now I have to find like terms. Or sorry, common denominator. Common denominator is going to be 75. So you're going to have negative 1 over 75 plus 25 over 75, which is 24 over 75. Okay. So it's not hard, but there are a lot of steps to it because you got to find the antiderivative. And if you need to use U-substitution, you're going to do that. And then you need to find, and then after that, you got to plug it in. Plug in, evaluate it, right? So it's not hard, but there are steps to it. There are steps to it, especially when you have to use, when you're doing a U-substitution problem. Okay? That's the one we're going to focus on the most is the U-substitution problems because those are the ones that students tend to struggle with. Now, I don't want to say struggle with. It's just, honestly, this is where I see most of the mistakes right here. This part right here. This is where I see most of the mistakes happening down here. And that has nothing, that's you guys, that's like math 1 stuff, right? It's just, I don't know if it's just like you guys do, sometimes students do too fast or what, but this is where I see a lot of the mistakes that happen. Not over here is the calculus. Like calculus, this is the calculus up here. Okay. So it's not so much with that. It's just being careful, taking your time. Okay. That's the main thing with this guy. Okay. Okay. So number 3. So what I want you to do for number 3 is picture that these aren't there. Picture that these aren't there. I want you to do it to that spot, and then we'll do that. So find the antiderivative. Picture these aren't there. You guys did that last week. So do that. I want you to do U-substitution. Just like we did last week, just like we did on our notes and in the assignment. I want you to do that. Get that far. And then we'll do the evaluation part together. Okay, so we had fractions and we had roots. So I had to change both of those. Split them up, give it a root. Okay. So after I did U-substitution, I got, let me put the U back in. I haven't put U back in yet. 5x plus 6 to the 3/4 power. Okay. This is going to be a lot easier if you're comfortable doing U-substitution. If you need to practice U-substitution on your own, do that on your own. It's not hard. There's tons of problems in our book that we haven't covered because we don't really use our book a lot. There's lots of examples in there. You have answers in the back of the book that you can practice. Okay? Because if U-substitution is a problem, this process is going to be even harder. So if you need to practice on your own, that's what this class is about. AP means practice on your own, okay, if you need to, okay? So if that process is a little bit, you're not where it needs to be, that's what you need to do, okay? So I've gotten there. That's where we stopped last week. The only part that's new is that I have to plug in 2 and -1. So I plug in 2 for x. Oops. Plug in -1 for x. And see what we get. Well, 5 times 2 is 10, plus 6 is 16, so I get 16 to the 3/4 power. Over here I get 5 times -1 is -5, plus 6 is 1, so I get +1 to the 3/4 power. What does 3/4 power mean? What is that? What does 3/4 power? What in the world does that mean?
The number cubed first and then taking the fourth root.
There you go, exactly. Top means power. Third power. Bottom means root. So it doesn't matter which one you do first. You can cube it and then take the 4th root, or you can take the 4th root and then cube it. I would suggest doing what's easier. Without a calculator, I can't do 16 to the 3rd power. And then find the 4th root of that? No. But what I can do is find the 4th root of 16. That's easy. What times itself 4 times makes 16? 2. That's 2. And then cube 2. 2 times 2 times 2? 8. 1, it doesn't matter because always 1. 1 cubed is 1. 4th root of 1 is 1. And there you go. Okay. Those are more likely the ones you're going to see. You won't see a lot, even though they're super gimme questions like that, like number 1. You won't see a lot like that. Maybe 1 or 2, but most of them are going to be like 2 and 3, where you have to use U-substitution and evaluate. Okay, those are the ones. That's the ones we're going to practice. Okay. All right, so let's throw in a trig one now. Okay. All right, so first thing, I see a root. I don't want a root, so I'm going to change it. We got tangent of x to the 1/2 power times secant squared of x dx. Okay, no more roots. And I move the squared to the end, more of an algebra look than a trig look. So I have 2 options. I can I actually have 3 options. You have 3 options. I can say tangent as a derivative, or sorry, as a u. I can say secant as a u, or I can say secant squared as a u. I have 3 options. Only one of them is going to work. What is a little... I told you guys about this last week. It's a trial and error process, but what will help you? What's a little trick you can use to figure out which one U is going to be? Because you have 3 options, right? And if it's a time test and you have 3 options, because most likely you're going to see, all of these problems are going to be multiple choice problems, right? So multiple choice problems, you only want to spend a few minutes on them. So what's something that will shorten your time so you don't have to try all 3?
I want to say which one is harder to solve, which one has it.
Not necessarily harder, but
we can see that the derivative of tangent x would be secant square x, so we can cancel them out and then it would be easy.
Exactly. That's what you want to look for. Pick a u that if I were to find the derivative of it, it's also in there. Right? If I were to pick a u, you want to pick the u where the derivative is in there. Right? If I were to pick tangent, what's the derivative of tangent?
Secant squared.
Boom, that one's in there. That means it'll cancel out, right? If I pick secant, what's the derivative of secant? Secant tangent, right? Well, that would be great, except I don't have a secant tangent anymore. I have just a tangent, right? So the u, that will kind of be a little trick to use, okay? But like I said, if not, trial and error, okay? So tangent of x, the derivative of tangent is secant squared of x dx. Divide by secant squared of x. So I get 1 over secant squared of x du equals dx. So I'm going to switch in for tangent, no more. It's going to be u. That'll leave secant squared. Well, then I put back in for dx 1 over secant squared, then they'll cancel out. So tangent becomes u to the 1/2 power times secant squared of x dx. Oops, not dx. Instead of dx, put in what it's equal to. Substitute that in. 1 over secant squared of x du. I want anything with an x to go away. And it does. So now I have u to the 1/2 power du. That is what I'm going to do the antiderivative. Now antiderivative. Add 1 to the power, divide by the new power. So it'll be 3 over 2. If I divide by 3 over 2, it's going to be times 2 over 3. It's the same thing, right? So 2/3. No plus c. I got to evaluate it now from here, from pi over 4 to 0, or 0 to pi over 4. Put a u back in. Tangent of x to the 3/2 power. Evaluate it from pi over 4 to 0. Okay. 2/3. So now let me plug in First thing I'm going to plug in is pi over 4. To the 3/4 power minus 2/3 tangent 0 to the 3/2 power So tangent of pi over 4. Tangent of pi over 4. What is tangent of pi over 4? 1. It's going to be 1. So 1 to the 3/4 power is just 1. Times 2/3 is 2/3. Tangent of 0. What is tangent of 0? Oh, yeah, 3/2. What is tangent of 0? 0. It's 0. So that means this guy is going to be 0. This guy right here is going to be 0. 0 to the 3/2 power is still 0. Times 2/3 is 0. 2/3. Okay. So like I said, a lot of times students focus on this, U-substitution, which is great. We did it last week. That's what we did. And then when I throw in this part here, they freak out. That's where they make their mistakes. I'm like, this is what you guys have been doing this for a while. This is not anything new. Just plug it in, subtract. That's all, right? But there's a lot of powers. There's a lot of squares. There's a lot of fractions. There's a lot. You just got to do order of operations. Make sure you take your time and do order of operations. I'll give you a hint. Anytime you have a weird power like 3/2 or 3/4 or 1/2 or whatever, more than likely you're going to have a clean answer. You're not going to have an ugly answer. You're going to have a clean answer. Like the last one, they're going to give you like numbers like 16 to the 3/4. That's a clean answer, 8, right? They're not going to give you something like 21 to the 3/4. That would be ugly answer. Same thing here. 1's big a lot. 0's big a lot. If you get down here and you're getting weird, crazy, ugly answers, probably did something wrong somewhere. This is a good way to check to see. If you get here and it's something that's clean, 16 to the 3/4, 1 to the 3/4, they're nice, clean answers, then you're probably in a good spot. Okay? All right. Let's see here. I want you to practice number 5. Do number 5. Try number 5. You evaluate it from 5 to 6. Okay, so when you rewrite it, -1 power, like I told you guys, anytime you see a -1 power, more than likely you're going to have to use some sort of, when you do antiderivative, you're going to have to do some sort of natural log.
U to -1 rewritten as 1 over u.
1 over 2.
1 over u.
Oh, yeah. That was my next step, yeah. So anytime you see anything to the -1 power, a u to the -1 power, this to the -1 power, should be a q that later on, it could be written as 1 over u, which is, you're going to have a natural log, right? Yep, you can also rewrite it like this, just for future reference. Because a lot of students get to that point and then they do the power rule and then they like, well, what do I do? That means you're going to have to use natural log. The antiderivative of 1 over x, 1 over u is natural log, just like the antiderivative or the derivative of 1 over x was natural log. So -2 times the natural log of u, and you have to evaluate that from 6 to 5. So remember, put bars around it because the number has to be positive. has to be positive. We don't know if it's going to be positive yet. So put bars around that. So it's going to be -2 times the natural log. Put u back in, 7 minus x from 6 to 5. -2 times, now we're going to actually evaluate. Plug in 6, plug in -5. So -2 times the natural log, 7 minus 6 minus -2 times the natural log of 7 minus 5. So 7 minus 6 is +1. What is the natural log of 1? 0. 0. The natural log of 1 is 0. What e to what power makes 1? 0. That's why it's 0, right? So, and then -2 times 0 is just 0. The natural log of 2, 7 minus 5 is 2. The natural log of 2 is a decimal. We can't use a calculator for this problem. So we're just going to leave it the natural log of 2. Okay? So this would be -2 times the natural log of 2. Which minus a negative becomes that. And you get 2 natural log 2. Okay? And you leave it like that. It's going to be a decimal answer, but again, if it's a non-calculator question, which these will be, that is what you're going to use for, that's what you're going to leave your answer as. Okay? 2 times the natural log of 2. Okay, last one we'll do today. Last one we'll do today. Tomorrow we'll finish and then we'll do some more practice. I'll probably have some more practice problems for you guys tomorrow. And then Wednesday we will, I'll give you your assignment. Okay, because I want to do 2 days of guided where I'm with you guys, and then I'll let you guys work on Monday, or Wednesday, sorry. Okay? Okay, so first thing, it's got an e, right? What's the derivative of e to the x power? And then so the antiderivative is e to the x power, so it's not that bad. It's got a -8 there, so this is what I would do first. I would split it up. We've done that before. You did that on the quiz. Okay, you don't have to do that, but I think it's just easier. What is the area of that guy going to be? 40. Yeah, 40. Right? It's got a height of 8, width of 5, right? So you don't even need to find the antiderivative. The antiderivative is just going to be 8x. And then you plug in 5, you get 40. You plug in 0, you get 0. 40 minus 0 is 0, right? But you guys can do that, so don't worry. So this part, just don't forget about it, but it's not the part where we're going to focus on. Okay? This is the guy we need to focus on. Can I use the power rule for this guy? No, right? No, because e is not an exponent. If this was x to this power, if this guy was x to this power, then great, go for it. But it's an exponential, right? X is up here. So this is what I'm going to have to do. I have to do U-substitution. Let me just put, this is a -40. For this guy. I have to do U-substitution for this guy here. What do you think U is going to be?
Negative 0.2.
The power, yeah, 0. U is going to be the power, right? U will be that power. So let's do that. So divide by negative 0.2, divide by negative 0.2. Okay. Let's put in what we got. So I'm going to move this guy down here. So negative 0.2 is the same thing as negative 1/5. So if you're dividing by negative 1/5, that's really the same thing as negative 5. Dividing by negative 1/5. That's really the same thing as multiplying by negative 5. Because you would have 1 divided by negative 1/5. Keep, change, flip, you get negative 5. Okay? So we have negative 40 on the outside, 5, 0, oops, e to the u power. E to the u power is the same thing. It stays the same. Negative 40 times e to the u power, evaluate from 5 to 0. Put in u. Evaluate it from 5 to 0. When I plug in 5, I get negative 1. So negative 40. When I plug in 5 here, I get negative 1. Negative 1 power means 1 over e. Negative 40 over e. I'm going a little fast because we're running low on time, but it's evaluation. This is not new. Plug in 0. That's going to be 0 power. E to the 0 power is just 0. Or sorry, 1. Negative 40. Get negative 40 e over e plus 40. And then you have to bring down the negative 40 you had before. The 40s cancel out, and you're left with negative 40 over e. Okay. So again, it's just about practice, like U-substitution. It's the same thing as U-substitution, just you plug in numbers afterwards. It's not bad, it's just practice. That's all it takes, practice. And that's what we're going to do tomorrow too. Okay, we're just going to keep practicing.